going to look at conditional probability today. And in our first box there on conditional probability, what it says is it says A, and then it says kind of a bar or a line, a vertical line, and then B. The probability of A bar B. Well, first of all, what that means is what we're looking at is that this is A given. The probability of A given B. I should have made that a capital A. And to figure out what that means, on the top, this is the probability of A and B divided by the probability of B. And until we see the examples, that probably doesn't make any sense to you at all. So let's look down here at the words and then we'll actually get into the example. But conditional probability, given by that formula, is the probability that an event A will occur given that the event B has already occurred. So this means that when you find the probability of event A given B, you're not choosing from all the possible. So you're not looking at the whole, all of the possible outcomes or the total sample space. You're only choosing from a select set of outcomes that fall into event B. In other words, event B becomes your new sample space. So what's on the bottom is the sample space that we're really looking at. And then one way of looking at it is the event that is second in the conditional statement. So after the bar, in this case of the B, is the event that's the second in the conditional statement will be the denominator, the bottom of your fraction when finding probability. Again, probably doesn't make sense until you see an example. So let's start like we always do by setting up the sample space. And our problem says an experiment is run where a number from 1 to 10 are picked at random. So when we start, we write out the sample space. We're going to call this set S. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our sample space. So that's the whole thing. But we're going to be applying the conditional probability to this. So in the end, we're not going to use all of that. We look at part B here. It says set B is picking an even number. So we're going to look back at our blue sample space, and we're going to figure out what are the even numbers from there. And our even numbers are 2, 4, 6, 8, 10. We're also going to look at a set A here. And the set A says find the probability of A. I'm not quite sure why I did that, but let's look first of all, what is set A? Set A is picking a multiple of 3. So we're going back into the blue, into that sample space, and we want to pick multiples of 3. 3 is a multiple of 3. 6 is a multiple of 3. 9 is a multiple of 3. And then if you want the probability of A, which kind of confuses the problem, and that needs to be fixed later on. But the probability of A, what we've been doing when we looked at the introduction to probability and even some of the union and intersections is, well, the probability of A is that we have 1, 2, 3 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you prefer, that's 0.3. But what I want to focus on is that set A is picking a multiple of 3. But here's the conditional, finally on part B. It says find the probability of A given B. That's what that statement says. So first of all, when we write this, our denominator is going to be set B, the second one. event B becomes your new sample space. So we're going to put 1, 2, 3, 4, 5. That's going to be our denominator. And now to finish here, it says find the probability of A given B. So now what we're going to do is that the probability of A is picking a multiple of 3. So we're going to look at the red numbers over here, and how many of those red numbers overlap the green numbers. So in other words, here the green is our new sample space, 2, 4, 6, 8, 10. How many from our green are a multiple of 3? Only one. The 6 is here, and the 6 is there. That's the conditional probability. If you want the decimal equivalent, it's 0.2. Now, I had one little confusing factor there in my set in letter C, which I think might confuse the whole issue. But my next example was a little bit better. So let's take a look at that one. And it even conceivably looks familiar. So it says, let's revisit a two-way frequency table chart we saw in the last lesson. In this study, we had 52 graduating seniors were surveyed as to their post-graduation plans, and then results were sorted by gender. So we've got M for male, F for female, C for going to college, N for not going to college. And then we've got our frequency table over here. And just to save a little bit of time on this, if we fill in our totals, here remember this should be 52. It says 52 graduating seniors. If we add 16 plus 13, we get 29. If we add 14 plus 9, we get 23. 16 plus 14 is 30, and 13 plus 9 is 22. So now we've got the totals in there. Use Desmos, use your calculator to get those totals. And an old problem here on part A, but then we can get into our conditional probability and get a little bit more practice with that. So part A says, find the probability of going to college. Well, recall that there's 52 seniors. So that's going to look at the total. Conditional doesn't look at the total. With just a straight probability, we look at the total. And then we want to look at going to college. So we're going to go across here, and going to college, we see that there's 29. And if you need the decimal, I'm not going to type it in right now for time purposes, but it's actually approximately 0.56. But now on the B, C, and D, now we get into the conditional. And once again, what goes second in here? So on problem B, the F is the second. So that's F for female. What goes second is going to go in the denominator, the bottom of the fraction. So when we look up here and look at our chart, we see that there are 22 females. And now what we want to look at is, out of those 22 out of those 22 females, how many of those females are going to college? And that's going to be the 13. Again, if we type that in, 13 divided by 22, if I typed it incorrectly, I got 0.59. What I want to stress again, what's listed second? So on part C, probability of C bar M, the M is listed second, so M is for males. Well, the males are going to go in the bottom. Well, we look at that, and what we see is that we've got 30 males. Well, now that we know that we've got 30 males, then out of those 30 males, how many are going to college? 16. And again, if I typed it in correctly, I got 0.53. And finally, when we're looking at these, the second one, probability of male given that they're going to college. The C is the second value there. That's what's going to go in the denominator. So we look up here, how many people are going to college? There's 29. And then out of those 29, and the question is, how many are male? Well, how many are male is 16. And if we type that in, we get the decimal of 0.55. So if we flip our paper over, recall that we read probability of A bar B as A given B. And I haven't been reading it that way, but I do need to stress that a little bit more. So when completing word problems, which is the problems that we have here on the back, a lot of at least, seeing the word given indicates that you will be using conditional probability to solve the problem. So example 4, there are 230 sophomores that take geometry, 206 sophomores that take algebra 2, and 32 sophomores that take both geometry and algebra 2. Find the probability of selecting a sophomore that takes algebra 2 given they're also taking geometry. So what we've got here is we want to find, let's see if I can write it in the proper format. We want to find the probability that algebra 2 and geometry, given that they're taking geometry. And if those symbols don't make sense, don't even write them down on your notes, because that's going to be too confusing. What I can say is, what comes after the words given is what's going to go in the bottom of our fraction. So what comes after the word given says they are also taking geometry. So when we look up there, how many students are taking geometry? Well, that's our first number. It's 230. There's 230 sophomores that take geometry. 206 take algebra 2 and 32 sophomores that take both geometry and algebra 2. So when we look at this top one, this top symbol, again just as a reminder, is that symbol, that upside down U means and. So the probability that you're taking algebra 2 and geometry, well, how many are there? Well, our problem says 32. And if we type that in, then, and I am fine with the fraction, it's approximately 0.14. As we look at the next one, the senior class is 55% female and 32% are females who play a competitive sport. Find the probability that a student plays a competitive sport given that the student is female. Just want to remind ourselves that the given is what's important here. And again, if you don't like the symbolism that I've been using, what comes after the word given is what's going to go in the bottom of the fraction, the denominator of the fraction, given that the student is female. Well, the senior class is 55% female. That's the first thing that's listed in there. Instead of writing 55%, I'm going to write 0.55. And I think that's why the state has us turn these into decimals sometimes. Because here's a percentage. So the 0.55, that's the female. Now what we want to find on top is who is female and involved in a competitive sport. So 32% are females who play a competitive sport. That's going to go in the top here. for our conditional probability, and we get approximately 0.58, and I know I haven't been typing it in. 0.32 divided by 0.55, which is, by the way, the 58%. We're just moving the decimal back and forth in terms of we move it 2 to the left to convert to a decimal, and 2 to the right to convert to a percentage. If you want the symbolism for this, it would be something like the competitive sport given that they're female. But what I want to stress is what comes after the word given is what's going to go in the denominator, in the bottom of the fraction. And this problem looks probably somewhat familiar. And what we need here is we need some totals. And to keep it short at least, I'll put the totals in. So when we add here, then we add here. So 0.15 plus 0.2 plus 0.05 is 0.4. 0.25 plus 0.10 is 0.35. 0.05 plus 0.05 plus 0.15 is 0.25. When I added those all up, I hope that it adds to be 1. Looking at the black hair color, when we add those up, we get 0.45. The blonde hair color is 0.35, and the red hair color is 0.2. And again, that should end up to add to be 1. So what we need to look at here is, first of all, it says find the probability the person picked had brown eyes given that they had blonde hair. There's the given, and frequently what you're going to see, and I've got a lot on here, but frequently what you're going to see is you're going to see me circle the word given. And what's going to go in the bottom? What's going to go in the bottom is going to be the blonde hair. So we look at the blonde hair. Find the probability that the person had brown eyes given that they had blonde hair. The blonde hair is going in the denominator. That's going to be 0.35. And then when we get the top of this, remember it's an and. And what we do with the table when we're looking for and. So find the probability that the person had brown eyes given that they had blonde hair. So we're going to go to the blonde hair column and the brown eyes row, and we're going to move our fingers until we find them intersecting. So start with your finger on the blonde, your finger on the brown, and go till the fingers intersect. And what happens is that they intersect at the 0.10. And again, we can finish here by typing that in the calculator. And it comes up, if I typed it incorrectly, as 0.29. Part B. Find the probability the person picked had black hair given they had blue eyes. Again, watch out for the given. And the thing is, when we're dealing with this given here, when we're looking at it, start with blue eyes. So looking above there, we look at the blue eyes, and we see 0.4. So that's the given. What comes after the words given goes in the denominator, goes in the bottom. So next, then, find the probability that the person picked had black hair. So we're going over here and looking at the blue eyes. Going in that column there, and in terms of black hair, what we see is we see the 0.15. And when we type that into the calculator, I'll let you do that typing. We get 0.375, or if you prefer, 0.38. Once again, watching out for the word given. So when we look at this one here, what is the probability that a person picked at random has green eyes or red hair? And I'm not actually looking for given in this one. We're looking at the or. So we have to go back to our green paper and deal with the or here. So what we're going to start with is we're going to do the probability that the person has green eyes plus the probability that the person has red hair minus the probability that they have green eyes and red hair. So it's an old problem. So we have to be watching out for not only the givens, but we also have to be watching out for the ors. And the probability that a person has green, let me read it again. The probability that the person picked has green eyes. So the probability that a person picked has green eyes is 0.25. And the probability that the person has red hair, my writing's not very good, but it's 0.2. And we're going to take away, remember we double count with those R's, so the probability that the person has green eyes and red hair, remember, just follow the column here. So go to the green, go to the red, and when your fingers overlap, we see that that's going to be 0.15. And when we type that into the calculator there, we should end up to be 0.30. So lastly, what is the probability that a person picked at random has blue eyes and blonde hair? Again, a couple of old ones to finish the notes, but where the person has both, we're going to go and look at the total here. It's probably the person has blue eyes and blonde hair. So go to the blue eyes, the blonde hair, and again where they overlap is going to be the 0.2. And if you're really one, it's over 1, but that's really 0.20.